we got problem number 1 over here, and it says that the coefficient of x squared in the expansion of this thing is 12 times the coefficient of x squared in the expansion of this thing. And so we need to find the positive value of the constant a. So what is a? So if you look at basically this guy right over here, it has a variable a. Okay, so what we're doing is they give us this information that the coefficient of this thing, the coefficient of x squared of this thing, is basically going to be something. So it's basically going to be something. And then the coefficient of x squared of this thing is basically going to be something. And then this thing right over here is basically 12 times this thing. Okay, so we have this information, and I'm going to show you guys how we can use this information to basically find the positive constant a. So what I'm going to do is I'm first of all going to have my two brackets, 1 minus 4x raised to the power 6, and I have my other bracket, which is 2 plus ax raised to the power 5, and I'm going to expand them both to get x squared. Okay, so how do I do that? Well, first of all, I'll do it for this guy. So I put in over here 6, choose 2, and then we're going to have 1 raised to the power 4 minus 4x raised to the power 2. And then I'm basically going to expand for this guy, and that's going to be 5, choose 2, 2 raised to the power 3, ax raised to the power 2. So let's solve both of these guys out, and when you solve this, you're basically going to get 240x squared, and when you solve this in your calculator, you're basically going to get 80a squared x squared. Okay, so now you have this, the x squared of this bracket, and you have the x squared of this bracket, and the coefficient, let's look at the coefficient. So over here the coefficient is 240, over there the coefficient is 80a squared. Now we know that basically this 240 is 12 times greater than this 80a squared. That's what they told us in the question. So let's make an equation for that. So we can say that 240 is basically 12 times 80a squared. Right, so now we have an equation, and we can basically solve for a. So this is just going to be 240 equals 960a squared. And what we're going to do is we're just going to make a squared the subject. But before that, let's divide 960. Let's take this 960 over there, divide it. So we're just going to get a squared is equal to 1 by 4. And now what we can do is we can just take this square over there to the other side. So this is just going to be square root 1 by 4. And we're just going to get 1 by 2. So that's the answer for a. For question 2, we are supposed to describe a transformation in a clear order in which they've been applied. So we have this thing, y equals x raised to the power 2, and we need to tell them the order of the transformations. So the first transformation that we can see that has been happening is that it's a stretch. It's a stretch by a factor of 4. So it's basically it's a stretch in the y-axis by a factor of 4, and so that is just going to be y equals 4x squared. And then what's happening is that we basically have a translation in the x-axis to the right by 3 units, and so that's just going to be x minus 3 whole squared. And so the other thing that we're having that's going on over here is we have another translation. We have another translation in the y-axis. To downwards. We will just call it downwards. Downwards by 8 units. 8 units. So this is just going to be y equals 4x minus 3 whole squared minus 8. This is the sequence of transformations that has been applied. 7 tan theta divided by cosine theta plus 12 equals 0. And they're saying that we need to show that it can be expressed as this something right over here. So let's try and do this. And I feel like my plan with this is I can, first of all, I have no fractions. So I'm going to try and get rid of this. And then I have no tans or no cosines. So I'm also going to try and get rid of those. So what we're going to do is, first of all, we're just going to get rid of that fraction. So I guess we can write 7 tan theta divided by cosine theta as 7 tan theta multiplied by 1 over cosine theta. And then this is plus 12 equals 0. Okay, so what we can do now is we can sort of break down tan theta, because we can see we don't have any tan theta in this. So we're just going to break down tan theta into into sine theta over cosine theta. And this is going to be multiplied by 1 over cosine theta plus 12 equals 0. So what's going to happen is we can sort of multiply the denominator. So we're going to get 7 sine theta over cosine squared theta plus 12 equals 0. Okay, I feel like now what I can do is I can sort of make this cosine squared theta disappear, because I'm not trying to do anything with that sine. I have sine in my final answer. I don't have cosine squared thetas. So let's see what I can do with that. I think we can change cosine squared theta into this thing where we know that cosine squared theta is basically just 1 minus sine squared theta. So let's try and replace it with that. So we're just going to have 7 sine theta over 1 minus sine squared theta. And then I have my plus 12 equals 0 over here. Right. So now I sort of still need to somehow get rid of my fraction. I didn't completely get rid of my fraction. As you can see over there, we don't have any fractions. So one way of doing that is, well, if I take this 12 to the other side, I'm basically going to just have a negative 12. And I feel like what I can do now to get rid of this fraction is just take this thing over there and multiply it with that negative 12. So I'll just have 7 sine theta equals negative 12 plus sine squared theta. My bad. This is actually going to have a 12 next to it. So it's a plus 12 sine squared theta. And I think now we already have something that looks really close to that. We can take the 7 sine theta over here to the other side, and we'll just get 0 equals negative 12 plus 12 sine squared theta minus 7 sine theta. And if we rearrange this a little bit, we can sort of get 12 sine squared theta minus 7 sine theta minus 12 is equal to 0. So perfect. We just proved that this thing is actually this thing. Okay, now we come over here to the next part, and it says, hence solve the equation 7 tan theta over cosine theta plus 12 equals 0, and it sort of gives us this range for theta. Now what we're trying to do over here is we're actually not going to use this, because we already know that this thing is that thing. So what we're going to do is we're going to say 12 sine squared theta minus 7 sine theta minus 12 equals 0. Okay, so this thing basically then has this range. And now I guess what I'm trying to do is I can see this is a quadratic equation because there's this sign which has a squared and then this sign has nothing on top of it. So what I can sort of say is I can say that my sine theta is basically x. And so now it'll actually start to look like a quadratic equation. You guys can see, there we go. That looks like a quadratic equation. I'm going to solve this quadratic equation out, see what happens. So one way I can solve this is using the quadratic formula. And I think that's what I'm going to do. I don't want to waste my time with middle term break and all of that stuff. So we're just going to write, we know it's minus b plus minus square root b squared minus 4ac over a. So I'm just going to put these values in here. So minus b plus minus square root minus 7 squared minus 4. A is 12, C is negative 12 over 2A. So 2 and A is 12. And I'm just going to do this in the calculator real quick. Okay, so one of the answers we get is 4 over 3. And then the other answer will be, so the other answer is negative 3 over 4. So these are the two answers. And since we know that we set this thing where sine theta was equal to x, so we can just say sine theta equals 4 over 3 and sine theta equals negative 3 over 4, right? So now all we sort of got to do is we already have that range. So I guess now all we're going to try and do is we are going to find out what theta is. So first of all, we're going to have our theta equals sine inverse 4 by 3. And this is going to be, so this one seems to be yielding a math error in the calculator. So this is math error. This is not going to be an answer. So then we're just left with this option right over here. And if we take theta equals sine inverse 3 over 4, this is basically going to be 48.59 degrees. And so since this value was negative, it was basically negative 3 by 4. What we know is that sine is going to be in the negative quadrants. So that means we're going to have this quadrant right over here and this quadrant right over here. So this right here is 48.59, and then this guy right here is 48.59. So that means that this is basically just going to be theta is equal to 228.59. Okay, so that wasn't the final answer. This is one of the answers. So this is 228.59. And then this entire thing is basically going to give us, so this is going to be theta equals 311.41. this is the second answer. Let's look at question number 4 here, and it says that we got a function f. It's defined as square root x minus 1 for this range, this domain. And they say find an expression for f inverse of x. So, well, that's really easy to do. Well, we just say that y equals f of x, and so that just means that y is equal to under root x minus 1. And now what we got to do is we just got to swap these two things over here. So we're just going to have x equals y minus 1, and then we'll just make y the subject. So we're going to have x plus 1 equals under root y. Then we square both sides. So we square this side, we square this side. The square root cancels with this square. We get y equals x plus 1 whole squared. And then all we got to say is we got to say that y is basically equal to f inverse of x. And therefore, that just means that f inverse of x is basically x plus 1 whole squared. Okay, so let's look at this graph over here. Let's look at part B. And part B says that we have a graph where the y-axis is basically representing g of x, and g of x has this equation, and x can be anything. Okay, so we got to state the range of g and explain whether the inverse of g exists or not. So if you look at the graph over here, all of this y-axis sort of represents all the possible values of the function g. So this graph basically gives you all the possible values that g can have. And you can see that this point right over here, this is the maximum value. And then you can see that from both sides, the graph is sort of going on, going on, going on, going on. And it's going to go over here to this x-axis. It's sort of approaching x-axis. And we know that at x-axis, the y-coordinate is equal to 0. So this is the smallest value. This is the smallest range that our function g is going to have, which is 0. And then the highest range is basically at this point right over here. And this point, if you notice it, it's basically the y-intercept. So let's check out what value it is. And how do we check this out? So we have the equation for g of x, which is basically 1 over x squared plus 2. And all we got to see is that we're trying to find that y-intercept value. So the way we do that is we know that at the y-intercept, the x coordinate is equal to 0. So we're just going to put x as 0 in here. And we're just going to get g of x equals 1 by 2. So the highest possible value that we can have is actually 1 by 2. And then the lowest possible value we can have is 0. So the range is basically going to be, it's g of x is greater than 0, and it has to be smaller than 1 by 2. Okay, and they say, does g of x exist or not? So we know an easy way to check that is to just imagine sort of a horizontal line, and to move that horizontal line up and down in our head, and see if the horizontal line cuts at a single point or a double point. And if it cuts at double points, then that just means that the horizontal test has failed. So we will just say g inverse does not exist since the horizontal line test fails. The horizontal line test fails as the horizontal line cuts at 2 points. Okay, so the g inverse does not exist. So we got part C over here, and we have a function h, which is defined as 1 over x squared plus 2, and then it has a range, a domain, which is x greater than or equal to 0. So now it says solve the equation h of f of x. So this is basically a composite function, and they say that this thing is equal to this thing, and this is the function f, and this is the x input of this function, and we have to give our answer in this following form, where a, b, and c are integers. Okay, so what do we do about this? Well, what we can do is we can first find out what h f of x is, and then we can sort of separately find out what f 25 over 16 is, and then we can put them together. So I'm going to go for this first. And what is h? So h of x is basically 1 over x squared plus 2. What is f of x? So f of x is basically it's square root x minus 1. And so what I'm going to do is I'm just going to put this thing inside this function, because that's how I get this function. It's a composite function. So my h f of x is basically going to be, I put a under root x minus 1 in place of the x. And so I square that, and then I have my plus 2 over here. So this is what my hf of x is. Now all I got to find out is what this bad boy is. So I have my function f of x, which is basically under root x minus 1, and I need to input 25 over 16. So this is just going to be under root 25 over 16 minus 1. And so I can basically write it as under root 25 over under root 16 minus 1. So this is just going to be 5 over 4 minus 1. And this is going to solve out to give me 1 by 4. Okay, so now I basically have, I know this is basically this thing, and this thing is basically that thing. And initially they told me to put these two things equal to each other. So I have my 1 over under root x. Oops, that was not supposed to happen. So this is under root x minus 1 whole squared plus 2 equal 1 by 4. What I can do is I can sort of cross multiply here, so I'm just going to get 4 equals under root x minus 1 raised to the power 2 plus 2. Okay, so how about we send this 2 over there to the other side, so we're going to get 2 under root x minus 1 whole squared, and then what I can do is I can take this square over there to the other side, so I'm just going to have under root 2 under root x minus 1. Okay, so now what if I just send this 1 over there as well, so I'll just be left with under root 2 plus 1 equals under root x. And now what I can do is I'm basically trying to get something for this x. So I don't want this square root. How about I get rid of this square root? So let's do that. Let's do that. The one way I can do that is I can basically take a square on both sides. And what that's going to do is, so this square root is going to get rid by using that square. And so I'm basically going to have x, and I can expand this using the identity a plus b whole squared. So I am just going to get a squared, which is going to be 2. I'm going to get 2ab, which is going to be 2 multiplied by under root 2. And I'm going to get plus b squared, so plus b squared is just going to be 1. So I think this is my final answer, because I can't do anything with this equation right here anymore. If I go up to my question statement, it says that I need to give my answer in the form a plus b under root c. Okay, so what I can do is I can simplify this. So this is just going to be, this 1 is going to add up with that 2. So I'll basically have 3 plus 2 under root 2. And so actually this thing is actually similar to the form they want me to give the answer in. I do have an a, I do have a b, and I do have a c. So this is my a, this 3 is my a, this is my b, and then this is my c. We're on question number 5 over here, and it says the first and second terms of an arithmetic progression are tan theta and sine theta respectively. And this is the range of what the angle can be. So what we need to do is they've told us what the angle is equal to, and we need to find the exact sum of the first 40 terms of the progression. So we basically need to find the sum of terms of an arithmetic progression. And so we know that the formula of that is basically Sn, whatever the sum is, okay, equals 1 by 2 multiplied by n multiplied by 2a plus n minus 1 d. So this is the formula. Now we know what n is, so n is given to us as 40. So we know that n is 40. This is going to be 40. What we don't know is we don't know what a is, and we don't know what d is. But if you go over here to the first line, they basically tell you that the first term and the second term are tan theta and sine theta respectively. So what we can do is we can basically find this a, and we can find that d, and I'm just going to do that over here. So for finding the d is the common difference. So we're basically just going to take the second term, which is sine theta, and we're going to subtract from it the first term, which is tan theta. And then we know what theta is because they give us the value for it. So we're basically going to put in sine pi by 4 minus tan pi by 4. And when you solve this out, you're basically going to get negative 2 plus under root 2 over 2 as your answer. So that is the common difference. And to find a, you know that the first term is basically given to you as tan theta. So you just put in the value of theta over here. This is going to be pi by 4, and a is going to be 1. So you can actually go ahead, put 1 in here, and you can go ahead, you can put the d in here. So that's basically going to look something like s of 40 is equal to 40 over 2 times 1 plus n, which is 40 minus 1, so that's just going to be 40 minus 1, and then d is just going to be negative 2, positive under root 2 divided by 2. And when you solve all of this out in your calculator, you're basically going to get the answer, which is going to be 390 under root 2 minus 740. Now, you don't want to solve this guy any further, because then you would get some answer in decimals, but that's not what they asked for, so they asked you to give them the exact answer. That's why you sort of need to leave it in this form over here. For part B, they basically give us the same first and second term, tan and sine, but this time they change the progression to a geometric one. And they give us a range, and then what they want us to do is they want us to find the sum to infinity of the progression in terms of theta. So one way we can do that is we basically know the formula that sum till infinity is basically equal to the a term, which is the first term, over 1 minus r. Okay, so what we need is we just need to find what 1 is, and we need to find what r is. And we need to find them in terms of theta, because that's what the question demands for. So what we're going to do is we can basically find our a. We know that the first term is basically tan theta, so a is just going to be tan theta. So you can go ahead and plug that in here, tan theta. And then we need to find what r is, and r is basically the second term divided by the first term. So this is the second term, sine theta divided by the first term, which is tan theta. And we can actually simplify this thing over here, because we know what tan is. We know that tan is basically just sine theta over cosine theta. So what we can do is we can sort of write this as sine theta divided by tan theta. And so that just means that sine theta is being divided by sine theta over cosine theta. And then we can sort of change this a little bit. We can put multiplication sign over here, take the reciprocal, we'll get this thing, and we can cancel out the sine thetas, and we'll basically just get cosine theta. So we can plug that over here in place of r, so that's going to be this thing. Now for part 2, what we're going to do is they basically give us some value for theta, and they want us to find the sum of the first 10 terms of the progression, and they need the answer in 3 significant figures. So we know that for a geometric progression, the sum of a finite numbers is basically equal to a multiplied by 1 minus r to the power n over 1 minus r. And so we've already found out what this is from the previous part. So a was tan theta, and r was basically cosine theta. So what we can do is we can put tan theta in here, and put tan theta in here, and then we can put cosine theta in here, and then we know that we know that n is basically 10. This is the n over here, and then this r is also going to be cosine theta. So all we got to do is we just have this value for theta, this value for theta, this value for theta, and they tell us what theta is. So we just put 1 by 3 pi in here, we put 1 by 3 pi in here, we put 1 by 3 pi in here, and we're basically going to get tan 1 by 3 pi multiplied by 1 minus cosine 1 by 3 pi raised to the power 10 divided by 1 minus cosine 1 by 3 pi. And so you solve this out, and you're going to get an answer of 3.46. So we're on question 6, and it says that we got a curve, and then we have this equation for the curve. And they say the curve has a minimum point, which they're calling A, and intersects the positive x-axis at B. So we're supposed to find these two coordinates A and B. Now, my plan with this is if you sort of look at, let's say, if you look at this part, finding B, the way I'm going to do that is I'm basically going to put my y equal to 0, and I'm just going to sort of solve this equation out. And once I do that, I'm going to get my b, because they say the x-axis. So if you look at this, we have the x-axis over here, and we have the y-axis over there. So for this x-axis, the y-coordinate is basically equal to 0. And so if I want to find a point for the curve where it intersects the x-axis, what I'm going to do is I'm going to go to the equation. I'm going to put my y equal to 0, and it's basically going to give me the value for x. Now, the way I'm going to find my a is basically I'm going to differentiate this, and they've told me that we have a minimum point. So I'm going to differentiate this, and then I'm just going to put the differential, the dy over dx, equal to 0, because the gradient at the minimum point is basically going to be equal to 0. So that's my plan for finding a and b. So let's check it out. And I have y equals to 2x minus 8x 1 by 2. So I'm going to differentiate this. So this is going to be dy over dx, and then I'm going to differentiate all of this stuff with respect to x. And so what's going to happen is I'm basically just going to get I'm going to get 2, I believe. Yes, I'm going to get 2, and I'm going to get negative 4x negative 3 by 2. If I'm not wrong, let me just check this this again. So 1 divided by 2 minus 1 is minus 1 by 2. Sorry, my bad. I don't know how I wrote 3 by 2 over here. This is 1 by 2. Okay, so this is what we have so far. And so we just need to put this guy equal to 0, because that's what's going to happen. I put this guy equal to 0, and I basically have 2 minus 4, and I can write this differently, so I can say x raised to the power 1 by 2. Okay, so I just took that power, and I took it to the fraction, so I removed the negative sign. And so I can actually go ahead and write it a little more cleaner. So I know a power of 1 by 2 basically means a square root, so it's going to be this thing. And now what I can do is I can send that 2 over there to the other side, so that's negative 2, negative 4. Okay, cancel out those negatives. Send that square root x over there. And so I have this thing, and now what I'm going to do is I'm going to divide this 2. So 2 1s are 2, 2 2s are 4, and I'm going to get square root x equals 2. So I'm going to take a square on both sides, and this square is going to remove that square root. So I basically just get 4 as my answer. So the x coordinate of a is 4. Now I need the y coordinate for a. Do I need the x coordinate, or okay? So I need the y coordinate as well. So the way I'm going to do that is I have my y equal to 2x minus 8 under root x. Okay, and so I'm just going to put 4 in here and 4 in here. So this is going to be 8 minus 8, and square root 4 is 2. So this is going to be y equals 8 minus 16. And so this is going to be minus 8. So a is basically 4 comma negative 8. Okay, so this is my first coordinate that I was supposed to find, which is A, and now I'm just going to try and find B. So B is basically, so the curve is basically intersecting the x-axis at B, and we know that at the x-axis, the y-coordinate is basically equal to 0. So I have my equation over here, y equals 2x minus 8 square root x, and what I'm going to do is I'm just going to put my y-coordinate equal to 0, and so I got 2x minus 8 square root x, and I'm going to do something clever over here, and I'm going to show you guys what that is. So I'm actually going to get this back to the power 1 by 2, okay, and what I'm going to do is, I'm going to turn this into a quadratic equation. And the way I'm going to do that is, well, because there's no other way of solving this other than turning it into a quadratic equation. So the way I'm going to do that is I'm going to say that x raised to the power 1 by 2 is basically equal to u, and therefore that means that x raised to the power 1 is going to be u squared. Okay, this is what I'm going to do. And so all I'm left with is 0 equals 2u squared minus 8u. So now it's actually a quadratic equation, and I can solve this out. So what I'm going to do is I can actually take the u out as common, and I'm going to be left with 2u minus 8. Okay, so now this entire thing is basically equal to 0. And so what I can do is I need to first put my u equal to 0, and then I need to put my 2u minus 8 equal to 0. And so this is going to be one of the answers, and then my other answer is going to be 8, and u is equal to 2 1s are 2, 2 4s are 8, so this is going to be positive 4. Now this is the value they want. Why? Because they say that it intersects the positive x-axis. So if this is the origin, if this is where x is 0, what I'm sort of looking for is I'm sort of looking for this side. This is where it's going to be positive, right? So if I basically, I said that if I go back over here, I said that my u was basically equal to this guy. I can basically substitute that guy back, and so it's equal to 0. And so this just basically means this power basically means a square root. So this is just this thing, and so I can take a square on both sides. So this is going to be x is equal to 0. So I don't want this. I don't want this, because again, if I go up there, I don't want the origin. I want this side of the origin where x has positive values. So that's why I'm going to go for this guy right over here. So then again, I'll just substitute my x back over here, and this basically means square root x. So I got this, and what I'm going to do is I'm going to take square on both sides. So this square is going to cancel out the square root, and then my x is going to be 16. So I just found out the x coordinate of b, and now what I'm going to do is I'm going to find the y coordinate of b. So I go back to my equation, which is y equals 2x minus 8 square root x, and we just pop 16 in here. So 16 minus 8 square root 16, right? So this is just going to be 2 times 16 minus 8 times 4. And so these two things are basically equal to each other. So when I minus them, I'm basically going to get 0. If you don't believe me, you can do this out in your calculator, but these two things are basically equal to each other. So my y coordinate is going to be 0, and so b has coordinates 16, 0. We got question 6, part B over here, and it says the diagram shows a curve with the equation y equals 2x minus 8x raised to the power 1 by 2, and the line AB. And then they've given us the equation for line AB. And we need to find the area of the shaded region between the curve and the line. Okay, so basically we need to find this shaded area. And the way we can do that is if you realize this curve is going to have some area underneath it, which is going to be all of this area. And then this line is going to have some area underneath it, which is going to be this area. And if we basically subtract the area under the line from the area under the curve, we are just going to get our shaded area. And what we need to do is we need to know our 2 points, which are A and B. And we do actually know these points because we found out about these points in part A. So the x coordinate of A was 4, and the y coordinate, the x coordinate of B was 16. Okay, so what we can do over here is we first need to integrate sort of this curve, and then we need to minus from it the area under this line. Okay, so how do we do that? Well, we can write over here, we can say the area under curve minus area under line. Okay, so what we can do now is we can just say, okay, integral from 4 to 16 of the curve. So the curve has the equation 2x minus 8 under root x. So I just converted that power to a third. And then minus the integral 4 to 16 of the line, which is basically 2x over 3 minus 32 over 3 dx. Okay, and so what I can do is I can basically combine these two integrals. I can combine these two integrals using my integral properties. So if you haven't watched my video on AS level integration, you should watch it's a playlist, you should watch that, you will know what I'm doing over here. So using my integral properties, I can combine these two integrals, and I will basically have 2x minus 8 under root x minus 2x over 3 minus 32 over 3 dx. Okay, so I just combine these two integrals. Now what I want you to do is I want you to solve these integrals, simplify this algebra, and when you do that, basically get an answer of 4x over 3 minus 8 under root x plus 32 over 3 dx. So this is the integral you're going to get after you simplify this entire bracket thingy over here. Now what we can do is we can basically integrate this stuff. So let's integrate it, and we are just going to get 4x to the power 2, and we're going to get a 6 underneath this, and then we can get for this guy we can change this third to the power 1 by 2, and so we are just going to have 8x raised to the power 3 by 2 divided by 3 by 2, and then we are going to have 32 over 3x, and we're going to have the limits as 16 and 4, right? So let's just simplify this a little bit. So we can simplify this, and we are just going to get 2 over 3x squared, and then we can simplify all of this stuff over here. And so what we're going to get is we're going to get 16 over 3x raised to the power 3 by 2, and then 32 over 3 is just going to stay as 32 over 3. And then, of course, our limits from 16 to 4. So now all you got to do is you just got to input your limits. You got to put in your 16 and then minus from it your limits of 4. Now I'm not going to do that because that's going to take a lot of space here for me. But when you guys do that, you are basically, when you solve out for, so I'm actually going to write it here for you guys. So this is what you're supposed to calculate. It's going to be 2 over 3 16 squared minus 16 over 3 16 3 by 2 plus 32 over 3 16. Right, all of this, you're going to minus from it the limit of 4. So that's going to be all of this. And when you do this, all of this is going to give you 0, right? And then all of this 4 is going to give you 32 by 3. And so you're basically going to have 0 minus 32 by 3. And so you're going to have an answer of minus 32 by 3, and you're going to be like, oh, why do I have a negative sign in there? Well, don't freak out because of that negative sign. The only reason you have that negative sign is because this area, this shaded area, is under the x-axis. That's what the negative sign tells you. So if this shaded area was above the x-axis, you would have got a positive area. So don't mind the sign over there. So don't mind the sign. Just say the answer is 32 over 3 units squared. Okay, that's your area. On to question number 7, and it says that the equation of a circle is something something, and then the line with equation y equals something something is tangent to the circle. And both of these equations have a constant a, and they want us to find the two possible values of constant a. Okay, so what does it mean when a tangent touches a circle? So if this is a circle and a tangent touches that circle at one point, then that basically, in other words, it means that you're going to have the equation of the line, you are going to have the equation of the circle. If you combine them both, then you're going to get a merged equation. And basically, that merged equation is going to have a discriminant, which is b squared minus 4ac. It's going to be equal to 0. The reason why the discriminant of the merged equation is going to be equal to 0 is because the line and circle only touch at one point. If they touched at 2 points, let's say something like this, then the discriminant would have been greater than 0. If the line touched the circle at no points, then it would have been smaller than 0. The discriminant would have been smaller than 0. In this case, the discriminant is going to be equal to 0 because they only touch at one point. So what we're trying to do is basically, we know that a line is touching a circle. So what we're trying to do is we're basically trying to merge their equations and see what we get. So we have this x minus 6 whole squared plus y plus a whole squared equals 18. So this is the circle. And then y equals, I'm actually going to write it as minus x plus 2a. So this is the equation of the line. What I'm going to do is now I'm going to combine them and form a merged equation. And the way I'm going to do that is that I know that this is a y, that is a y. I know that this y is equal to all of this, and so I'm just going to substitute all of this into that y. And so basically by doing that, I'm basically solving two equations simultaneously, or in other words, I'm basically just merging the two equations. So I'm basically going to have x minus 6 whole squared plus minus x plus 2a plus a whole squared equals 18. And then what I can do is that I can basically simplify this. So this is going to become this thing, and I'll have minus 6 whole squared x over here. And now what I can do is I can basically expand these brackets out by using my identity. So what identity am I going to use? Well, I'm going to use a minus b whole squared over here. So this is just going to be x squared minus 2ab, so that's going to be 12x, and that's going to be plus 36. And then if I sort of rearrange this, I can write it as 3a minus x, and so I'm going to use a minus b whole squared over here as well. And so this is just going to be 9a squared minus 6ax, and then plus x squared. And all of this is equal to 18. What I'm going to do is I'm going to simplify this a little. So this x squared and that x squared are going to add up, give us 2x squared. And then this negative 12x, and that term with an x, I'm going to put them together. So negative 12 and negative 6ax, this is negative 12x. And then what I'm going to do is I'm going to put, this is a constant term because it doesn't have an x. This is also a constant, so I'm going to put them together. So plus 36 plus 9a squared equals 18. And I'm going to bring this 18 to the other side of the equation. So I'm going to have 2x squared minus 12x minus 6ax plus 36 minus 18 plus 9a squared equals 0. And I can simplify this, and I'm basically just going to get plus 18 plus 9a squared equals 0. Now over here, I basically have a quadratic equation. I'll show you guys how I have a quadratic equation. So what I'm going to do is I'm basically going to factor out this x and this x in these two terms. So that's basically going to look like 2x squared plus minus 12 minus 6a, and I factored out the x. And then this is plus 18 plus 9a squared. And what I want you to see is I want you to write down the standard form of a quadratic equation, ax squared plus bx plus c, and you can see that all of this is constant, all of this is c, all of this is going to be b, and all of this is going to be a. Now what I'm trying to do is, remember, I'm trying to find the two possible values of a. Now the problem is that I have an equation, which is this equation right here, the merged equation if you want to call it, and the problem is that I have one equation, and I have two unknowns in it. One of the unknown is x, the other unknown is a. So I cannot solve one equation for two unknowns. I can only solve one equation for one unknown. So this equation cannot be solved, and therefore I cannot find the value of a. But what I can do is I can get a different equation by using this idea over here that the discriminant is going to be equal to 0. And once I do that, I say b squared minus 4ac equals 0. I can basically just put my b over here, my a over here, and my c over here, and what you will realize is that I'm just going to write this out. So b squared is going to be negative 12 minus 6a whole squared. And then I'm going to basically have 4, a is 2, and then c is 18 plus 9a squared. And what you can see right now is now I get a new equation, and this equation only has one unknown, which is a. It doesn't have an x. So that's why this discriminant technique is so useful to us, is because it allows us to solve just for a. And this equation does not have an x. So what are we going to do now? Well, let's just simplify this equation a bit. So what I'm going to do is I'm basically just going to take negative 1 common out of these two, and then I'll basically just have 12 plus 6a, and all of this is a whole square. So what I'm basically going to get is I'm basically just going to get negative 1 squared, and I'm going to get 12 plus 6a squared, and then all of that, so negative 4 times 2 is going to be 8, and then I have 18 plus 9a squared over here. And so all of this is just going to give you negative 144, negative 72a squared. Don't forget the equal to 0. Okay, and so this negative 1 squared is just going to be positive 1. And then I can apply my identity over here for this. So it's just going to be a plus b whole squared. So a squared, which means 12 squared, that's going to be 144, plus 2ab is going to give you 144a. And then 6a squared is just going to give you 36a squared. Minus 144 minus 72a squared equals 0. Okay, so now I basically have 144 plus 144a plus 36a squared minus 144 minus 72a squared. Let's simplify all of this a bit. So this 144 cancels out that 144. And so this negative 72a is going to cancel out with that plus 36a squared. So I'm basically going to have negative 36a squared. And this 144a is just going to stay the way it is. And all of this is equal to 0. So now what I can do is I can basically factor this equation. I'm going to do it over here. I can basically factor this equation. So I can take the a common. So it's going to be negative 36a positive 144 equals 0. So all I did is I just took the a out as common. So now I'm going to have this thing is going to be equal to 0, and this thing is going to be equal to 0. So a is equal to 0, and negative 36a plus 144 is going to be equal to 0. Take the 144 over there to the other side. That's just going to be negative 144. And then divide negative 36 over there. You're going to get your answer as 4. So the two answers are a equals 0 and a equals 4. That's what you were trying to find, the two possible values of the constant a. Now you go over here, and they say that for the greater value of a, you need to find the equation of the diameter, which is perpendicular to the given tangent. So what we need to do is we still have that circle, we still have that tangent, and what they want us to do is they're like, okay, there's a diameter of the circle that's going to be perpendicular to this tangent. We want you to give us the equation for that tangent. So here's the plan. Here's what I'm going to do. Since this line is perpendicular to that diameter, the gradient of this line, the gradient for this line, and the gradient for the diameter are just going to be negative reciprocals. So if I know the gradient of my tangent, I'm going to negative reciprocal it, and I'll find the gradient of my diameter. And then over here where the circle touches this tangent, they meet at a point, they meet at a coordinate. And the diameter is also going through that point. It's also going through that coordinate. So that means that this coordinate is common for the tangent, for the circle, and for the diameter. So if I know what that coordinate is, and I know this gradient, I can basically use the point slope form to find out the equation for this diameter. That's what I'm going to do. So the first thing I'm going to do is I'm going to find the gradient for the diameter, and I can do that. So my equation of line was basically this thing, y equals 2a minus x, or in other words, it's y equals minus x plus 2a, and they want us to use the greater value of a, so we're just going to say minus a plus 2 times 4. One value was 0, one value was 4, 4 is the greater 1, so we're just going to get this thing over here. And then the gradient of this line is basically equal to minus 1, so the diameter being perpendicular here is just going to have the negative reciprocal of minus 1, and the negative reciprocal of minus 1 is just going to be positive 1. So how is that possible? Well, you have this negative 1, so you just multiply it with a negative, and it becomes a positive 1, and then you take a reciprocal of 1. So you take a reciprocal of 1, and it's just going to be 1. So the answer is positive 1. This right here is the gradient of the diameter. Okay, now we're trying to find that common coordinate. Okay, that intersection point of all of these three lines of the circle, the tangent, and the diameter. So how I can do that, one way of doing that is basically using that merged equation. So this merged equation I formed, this merged equation I formed, what I can do is I'm going to write this merged equation down over here. Hold on. So this is 2x squared plus minus 12 minus 6a x, and then I believe it's plus 18 plus 9a squared. Plus 18 plus 9a squared equals 0. Okay, so what I'm doing over here is that this is the merged equation. This is the merged equation of the tangent and the circle. And so the function of this is to tell me the coordinates where the tangent intersects with a circle. That's what a merged equation does. So what I'm going to do is I'm just going to plug in the values for a, which are 4, because they want us to use the greater value. So that's what we're going to do. So this is going to be 2x squared plus 12 plus minus 12 minus 6 times 4 x over here, and then 18 plus 9, 4 squared is equal to 0. Let's solve this out and see what we get. So this is going to be 2x squared. So all of this is going to solve out to give you minus 36x, and then all of this is going to solve out to give you plus 162. And so this is the final equation that you have, the final merged equation that you have. And now what you can do is you can solve this merged equation, and it's basically going to give you the coordinates where the tangent intersects with a circle. So let's solve it out. So the one thing we can do is we can just take the 2 common. So we're going to take the 2 out as common. Okay, and then we can send the 2 to divide over there. And so we're just going to get this equation. And what we can do now is we can sort of basically use the quadratic formula, which is minus b plus minus b squared minus 4ac over 2a. And when we solve this out, we should technically get the coordinates. So you get just one coordinate when you add or when you subtract. You just get one coordinate, that is 9. You get the same coordinate when you add or subtract. So if this is the intersection point, we know the x coordinate is 9, and now we just need to find the y coordinate. So what we can do is we can just you can actually go and put this into the circle equation, or you can go and put this into the line equation, or you can put the x-coordinate in any of these equations, and it's basically going to give you the y-coordinate. I'm just going to choose the line equation because it's just simpler like that. So the line equation is basically y equals minus x plus 8, and we're just going to put this coordinate in here. This is y equals minus 9 plus 8, and we're going to solve this out. So this is just going to give you negative 1. Okay, so weirdly enough, what we found out is that all of this circle is sort of going on there in the negative part. So this would, if there's a line like this, this would be the coordinate. This 9 is the x coordinate, and then the y coordinate would be minus 1. So we do have this point over here that we were trying to find. It's basically 9 and minus 1. So now we have the point and we have the gradient, which was positive 1. So we can actually go ahead and we can find the diameter equation. So how we're going to do that is we're going to use the point slope form. And then again, I'll just say this once again. We found out that the circle and the line intersect at a common point, and then the diameter is also sort of going through that point. So it's this point is common for all three of these shapes, you can call it. So we're going to have y minus y1 equals mx minus x1. So what we're going to do is we're just going to put the y coordinate in here, which I believe was negative 1, yes, negative 1, and then the gradient was just 1, and then the x coordinate was 9. So this is going to solve out and give me y plus 1, and then x minus 9, and then I can sort of send this 1 over there to the other side. So basically have x minus 10. And this right here is the equation for that diameter. We got question number 8 over here, and it says the diagram shows a symmetrical plate ABCDEF. The line ABCD is a straight line, it's this top line, it's straight. And then the length of BC is 2 centimeters. Each of the two sectors, ABF and DCE, is of radius r centimeters, and each angles, ABF and DCE, is equal to 1/3 pi radians. It is given that radius is equal to 0.4 centimeters, and we need to show that the length of EF is 2.4 centimeters. So this is E, this is F. We need to show that this length is basically equal to 2.4 centimeters. Now, we do know this length BC, and this length BC, this is 2 centimeters. So that means if we can find out this length and this length, then we can basically add all of them up, and we can basically get the length EF. Now, what's important here is that they said that the plate is symmetrical. What that means is it means that this length is basically the same as this length. So all we need to do is we need to find one of them, and the other one is going to be the same. So what we are going to do over here is we're basically going to take a look at this section over here. And if I draw this section out for you guys, it's basically going to look something like this. Now we have a triangle, and we have a sector over here. And then there's this angle that is pi/3 radians. And what I want you guys to notice is that this angle is basically the same as this angle. And the reason for that is because this is a straight line. This is a straight line as well. And so these happen to be alternate angles, and alternate angles are equal to each other. And then the other thing that I want you guys to notice is that they told you the radius of this sector. So this sector, and I mean this sector as well, it has radius r. So what that means is that this side is r, this side is also r. So basically this triangle, if I sort of extract this triangle out, this side is r, okay, and they told us in the problem that r is equal to 0.4 centimeters. So we have the value of r, and we know what this angle is. So we can actually find this bottom side that we're looking for. So what we're going to do is we're going to say r cosine pi/3 is basically equal to that bottom angle. And r is basically 0.4 centimeters. So it's 0.4 cosine pi/3. When you solve this out, you are going to get 0.2 centimeters as your answer. And this is basically this length right over here. This is 0.2. That means that the other side also has to be 0.2. And so when you add all of them up, so you add the 0.2 plus the 2 plus the 0.2, you can show that EF is actually 2.4 centimeters. Now you go on to part number 2, and it says find the area of the plate. Give your answer correct to 3 significant figures. Now, what we do is we basically go to our plate up there. I'm just going to erase some of this stuff. Okay, we're going to go to our plate and see what we're trying to do is we're trying to add all of these areas up. So we have two sectors, this guy, and then we have a trapezium in the middle. And so what we're trying to do is we're trying to add the area of the two sectors and this trapezium. So let's do that. And so what we're trying to do is we're just going to take the area of one sector, and we are going to multiply it by 2 because there are two sectors. And then we're going to add the area of the trapezium, Okay, so the area of the sector is basically, we know that it's 1/2 radius squared multiplied by theta. And then the area of the trapezium is 1/2 side 1 plus side 2 times height. So over here we know that this r is basically 0.4, so we're going to square that. The theta is pi/3. And then over here, we got this as 1 by 2. Side 1 is the top of the trapezium is 2 centimeters. The bottom of the trapezium is 2.4 centimeters. So it's 2 plus 2.4. And what is going to be the height? So well, we can find the height. This right here is the height of the trapezium. And we can find out using this same triangle over here. So all we got to do is we got to realize that this was r, this was pi by 3. And so this height is just basically going to be r sine pi by 3. And r is basically equal to 0.4. So it's 0.4 sine pi by 3. And you solve this out and you're going to get under root 3 over 5. So the height is basically under root 3 over 5. And then you basically, when you add both of these up, this guy and this guy, you're basically going to get your answer in the three significant figures as 0.930 units squared. Or actually, no, it's not units squared. The units were centimeters, so it's centimeter squared. Let's erase that s. So now we go over here to part B, and it says it is given instead that the perimeter of the plate is 6 centimeters. Find the value of r. Give your answer correct to three significant figures. So now what they've done is they're like, okay, imagine you didn't have the value of r. You didn't know that r was basically 0.4. And maybe r was something else. And all we're going to give you is we're going to give you the value for the perimeter, which is 6 centimeters. Using that, find the value of r. So how do we do that? Well, you go up over here and you ask yourself, what even is a perimeter? So a perimeter is basically the sum of all of the sides of this shape. So how many sides are there? Let's look at that. So basically, there's going to be this radius r, this 2 centimeters, this radius r, this arc length s, then this side, which is 2.4 centimeters, then this arc length s. Now you add all of these up and you put them equal to 6, then that's how you're basically going to find the value for your radius. So let's do that. Our perimeter is basically equal to r plus 2 plus s plus 2.4. So these are all of the sides. I'm just going to show you guys again. R, 2 centimeters, 2.4, s, and s. So I just added all of those sides up. And I know that my answer is going to be equal to 6. So, but what is this s? I don't want the s. I want to find an r. And if I have an equation, like let's say this is r, this is another r, this is 2, this is s, and this is 2.4, then the problem with this equation is that it has two unknowns, r and s. So I can't solve this equation for one unknown. I have two unknowns over here. I cannot solve this equation. So instead what I'm going to do is I have this thing called the s, and I'm going to basically write it in terms of r. That way this equation is just going to have one unknown, and that's going to be r. So the s is basically the arc length. We know the arc length has a formula that is basically equal to r theta. Okay, so what's going to happen is that I can basically have r plus 2, and instead of s I can write r theta, and then I can write r theta over here, and then I can write 2.4 over here. So this is going to be 6, r plus r is 2r, and then 2 plus 2.4 is going to be 4.4, and then r theta plus r theta is going to be 2r theta. And now what I can sort of do is this thing has 2r, this thing has 2r, so I can take this out as common. So this is just going to be 2r. I take 2r common out of this thing and out of this thing, so I'm just going to be left with 1 plus theta, and then I'm going to have my plus 4.4. Okay, and now what I'm trying to do is I'm trying to solve for this r. Do I know what my theta is? Yes, I do know what my theta is. Theta is pi by 3. Okay, so this perimeter is going to be 6. This is going to be 2r. This is going to be 1 plus pi by 3. And then this is going to be 4.4. So what I can do is I can basically send this thing to the other side. And I can sort of add these two things together. So I'm going to get 2r, 2.047. And basically, this 4.4 subtracts from that 6. I'm going to be left with 1.6. So now what I can do is I can basically just multiply these things. And when I do that, I'm going to be left with 4.094. And then I can basically divide this thing over there. And I'm going to get 0.390 centimeters as my radius. We got question 9 over here, and they say that a function f is such that its derivative, f prime, is equal to this equation right over here. And they say that x can be anything, any number. So determine the set of values of x for which the function is decreasing. So basically, this f is going to be some function, some curve, and they want us to tell them the values of x for which the function is decreasing. So what they mean by that is, let's say if I have the x-axis over here, the y-axis over here, and let's say in the y-axis we have our function f of x. So let's say if the curve does something like this, I know it's not a parabola, I'm just using this as an example, then basically if this right here is the turning point, then after the turning point, all of these values are basically where the function is decreasing. Let's say the function was 30 over here, then it's basically decreasing. It's going down, the value of the function is decreasing. So they want us to give them the values of x for which the function is decreasing. So let's say if this turning point was at 7 and this point was at 10, then basically from x equals 7 to x equals 10, the function is decreasing. Okay, so how do we tell them that the function is decreasing? How do we tell them that? Well, it's really easy. So they give us this equation for the derivative of function f. And in other words, f prime of x just means dy by dx. So they give us this equation for dy over dx. And so what we're trying to do is, you can see that whenever the gradient, this dy by dx is also the gradient, whenever the gradient is negative, that's when the function is decreasing. That's when the function values are decreasing. If I just draw that same axis over here, x and f of x, and I get the same parabola, as that's the turning point, and then it's going down, you can see that basically if this is the turning point, then this side of the turning point is going to have negative gradient. It's going to be horizontal at the turning point, and then it's going to get vertical, and then more vertical, and then more vertical, but all of these gradients are going to be negative gradients. And so you can see that for this region where the gradient is negative, that's where the f of x values decrease. And if you look at this region over here, this is where the gradient is positive, that's where the function increases. So a negative gradient literally means that the y values are decreasing, or that the function values are decreasing. So what we're trying to do, the reason they've given us this equation for the gradient, is because they want us to find the region where the gradient is negative. And that just means that they want us to find the region where f of x is decreasing. So negative gradient means the function values are decreasing. So how do we do that? Well, I'm just going to assume, let's say the graph looks something like this. Like, I'm just going to use the example of a parabola. I don't know if this graph is a parabola or not, but let's just take an example of a parabola. So what we're going to do is we're basically going to try and find what the x coordinate is for the turning point, and then we're going to look on this side of the turning point as well as this side of the turning point, and we're basically going to see that, okay, is the right side of the turning point negative, or if the left side of the turning point is negative. So we'll basically check out which side is negative, and whichever side is negative, whichever side has the negative gradient, that's where the function is decreasing. That's where the y values are decreasing. So what the plan is to basically find the turning point. Once you know the turning point, you basically check the right and left side of the turning point. And so whichever side you find the negative gradient on, that is the side where the function is decreasing. Okay, so that's the plan so far. So what we're going to do is we have this thing, which is f prime of x, and it's basically 6 2x minus 3 raised to the power 2 minus 6x. So what we're trying to do is we know that this is basically dy by dx, f prime is dy by dx. So since we're trying to find the turning point, we're just going to put 0 over here, because the gradient at the turning point, we know that it's equal to 0. And so we're going to be left with this thing. And so what we're trying to do is we're just trying to find the x coordinates where the turning point exists, or in other words, where the gradient is 0, and the gradient is 0 on the turning point. So we're trying to find the x coordinate of the turning point here. And one way I can do that is, while this equation right now is not expanded, I can expand it out first. So this is going to be 0, and then I can use my identity, so that's just going to be a squared minus 2ab plus b squared. Okay? And so I can just multiply everything with a 6, so this is going to be 24x squared minus 78x plus 54 minus 6x. Okay, and so this is going to be 24x squared minus, my bad, this was 72. This was 72, and this is now going to be 78, because this thing, right, with this thing is going to give us negative 78x. This is going to be plus 54. Okay, and so now we basically have a quadratic equation over here, and we can solve it, and we can find the x coordinates where the turning point exists. So we're basically going to make use of the quadratic formula over here. So minus b plus minus b squared minus 4ac divided by 2a. And so you're going to get two values. One of them is going to be 1, the other one is going to be 2.25. Right, so basically, if I draw a line over here, basically, these are your 2 points. These are your 2 points. This region over here is where we're going to have our gradient, and the bottom region is where we're going to have our x coordinate. So when the x coordinate is 1, and when the x coordinate is 2.25, that's when the gradient is 0. In other words, that's when we have the turning points. Okay, so now we basically want to check this side of the 0, and this side of the 0, and then this side of the 0, and then this side of the 0, to basically see which side is going to have the negative gradient, because that is where the function is going to be decreasing. So let's check out this first side first, and this side is basically to the left of 1. So you can pick up any value that is less than 1. I'm just going to make it simple and pick up 0. So we have our gradient dy over dx equals, we have the equation. So you can use any equation you want. You can use the equation that's not in the expanded form. You can use the equation that is in the expanded form. It is completely up to you. So I'm just going to use this equation, x squared minus 78x plus 54. Now if you put 0 in here and 0 in here, because I chose 0, then this thing is going to be 0, this thing is going to be 0, and I'm just going to be left with positive 54. So positive 54 is a positive number. That means on this side of the 0, we have positive gradient. Okay, so we don't want this region. We don't want this region. Why? Because this is where the function is increasing. This is where the gradient is positive. So now let's check out this second region over here. So let's do that. Now I can pick up any value between 1 and 2.25. I'm just going to use 2, and so my gradient is dy over dx. And this time I'm going to make use of the factorized form. So 6 2x minus 3 squared minus 6x. Let me just see if this is the equation. Yes, this is the equation. Okay, so let's solve this out. Let's put 2 in there. 2 minus 3 squared minus 6 multiplied by 2. So this is going to be 2 times 2 is 4. 4 minus 3 is just 1. Squared minus 6 times 2 is 12. So this is going to be 6 minus 12, and that's just going to be negative 6. So this is a negative gradient. In the second section, we have the negative gradient, which means this second section is where the function is decreasing. But we have one last section to check, so let's check that one out as well. So this time we're going to set x equal to 3, and therefore our gradient as the equation 6 to, in place of x, we're going to put 3 minus 3 squared minus 6 times 3. So now this is going to be 6, and then 2 times 3 is 6. 6 minus 3 is 3, and 6 times 3 is 18. And so 3 times 3 is 9, and then 9 times 6 is 54. 54 minus 18 is going to give us a positive number, okay? We're going to get a positive answer, which means that the third section is also positive, so the function is going to be increasing in the third section as well. That means the only section where the function is decreasing is when we have our x values between 1 and 2.25. That's the only place where the gradient is negative, and therefore that's the only place where the function is decreasing. So what we're going to do is we're just going to say that the function is decreasing when x is greater than 1, but it's smaller than 2.25. So this right here is our answer. Now we move on to part B, and it says that given that f of 1 is equal to negative 1, find f of x. So what we need to do is we basically need to find an equation for f of x. We don't know what that is. We need to find an equation for that. And one way we can do that is, well, we know that f prime of x is basically equal to 6 multiplied by 2x minus 3 whole squared minus 6x. So what we need to do is we just need to integrate this. So we just need to sort of integrate this. And I'm going to do it on the side over here because I don't like this function notation. So instead I'm just going to say dy by dx is equal to 6 2x minus 3 raised to the power 2 minus 6x. So what I'm going to do is I'm going to send that dx over there to the other side. 2x minus 3 whole squared minus 6x dx. And then I'm going to integrate both sides. So integrate this side as well. Minus 3 whole squared minus 6x dx. Okay, and then I'll basically just get y over here. And what I'm going to do is this right here is again this the factored form. We've already seen that if we expand it out, if we expand this guy out, we basically get this guy, all of this. So I'm just going to replace all of this with all of this down there. So this is 24, integrate 24x squared minus 78x plus 54 dx. All of this is just going to integrate to 24x cubed over 3 minus 78x squared over 2 plus 54x, and don't forget your plus c because this was an indefinite integral, right? So then we can just say that when we integrate this, we basically just get f of x equals 24x cubed over 3 minus 78x squared over 2 plus 54x plus c. And so we can simplify this a bit. And so we're just going to get 8x cubed minus 39x squared plus 54x plus c. And how do we find that c? Well, that's why they've given us this sort of information over here, saying that when x is 1, the f of x is just going to be negative 1. So we plug all of that in here. And when you are going to solve this out, all of this is going to give you 23. And so you take the 23 over there to the other side, it's just going to become negative 24 equals c. Okay, and then you can sort of just say that your f of x is equal to 8x cubed minus 39x squared plus 54x plus, minus 24. This is going to be your final answer. So we got question 10, and they say the equation of a curve is y equals brackets 5 minus 2x whole power of 3 by 2 plus 5 for this range. Okay, so this is the equation of a curve, this entire thing. And it's only true for the values where x is smaller than 5 by 2. Okay, and now they say a point P is moving along the curve in such a way that the y-coordinate of point P is decreasing at 5 units per second. So there's this point P that is moving along I guess, this curve, and it's moving in such a way that the y value, the y-coordinates of this curve are sort of decreasing at 5 units per second. So let's say each second they would reduce by 5. Let's say if the curve is something like this, then if the point is over here and after 1 second it moves to this place, then basically the y value difference between these 2 points, that's going to be 5. So what they basically told us is they're saying that the dy over dt, where this dt is time, and we're saying that the y is changing with respect to time and at a rate of minus 5. So this thing basically means that y, instead of having dy change with respect to dx, we now have our dy changing with respect to time, and it's decreasing, so we put a negative sign there. It's decreasing by 5. So that's why I put the negative 5 over there. So I have a quantity that's dy over dt equals negative 5. Okay, now we need to find the rate of the x-coordinate of the point P, which is increasing when y equals 32. Okay, so what we need to do is we basically need to find how the x-coordinate is changing when we're at this y equals 32. So of course, I'll go back to this example over here. As I go from point 1 to point number 2, not only is my y value going to change, but I'm also going to have some change in my x value. So my x values are going to change as well. So they're basically saying that when there's this point P, when it's basically moving, and it's, let's say I have on my axis, I have, like, let's say 32, this is my y-axis, I have a 32 over here. Let's say I have my curve over here, and let's say the point P reaches this y equals 32. That's when I have to tell how the rate of this is, how the rate of the change of the x-coordinate is going to be with respect to time. How the x-coordinate in this particular scenario is going to be changing with respect to time. So I basically, in other words, I basically have to find the dx over dt when P is at y equals 32. Now, if that doesn't make sense, I want you to rewind the video and listen to what I just said. So the way I'm going to do that is I'm basically going to make use of the chain rule. Why am I going to do that? Well, because the chain rule tells me something. If I'm trying to find dx by dt, then I can basically find it by multiplying dx over dy by, so if I can multiply that with dy by dt, and this makes sense because if you look at it, what's going to happen is that this dy is going to cancel out that dy, and so I'm just going to be left with dx over dt. So what I need to do is I basically need to multiply this thing right over here with this thing right over here, and that is basically what my rate of change of the x-coordinate is. That is what my dx over dt is. So that is what I am going to do. Now, how do I do that? Well, I already know what my dx over dy is. No, actually, I don't know that. That's what I'm trying to find. I do know what my dy over dt is. That's what they told me. They told me that it's negative 5. So I do need to find out whatever this thing is going to be. And how do I do that? Well, I make use of this equation. I have an equation, y equals 5 minus 2x, and this is going to be 3 by 2 plus 5. So what I'm trying to do over here is I'm not trying to find dy by dx. Instead, I'm trying to find dx by dy. So what I'm going to do is I'm going to make x the subject in this equation, and then I'm going to differentiate the equation with respect to y. And then I'll basically just get my dx over dy. So let's see what that's going to look like. So what I'm going to do is I'm going to send this positive 5 over there to the other side. So I'll basically have 5 minus 2x 3 by 2 equals y minus 5. And then I'm going to get rid of this power. So this is going to be 5 minus 2x equals y minus 5. And I have the power is going to change to 2 by 3. And then I'm basically left with this 5. And so I am going to have 5 minus 2x equals y minus 5, 2 by 3. So I just send this 5 over there to the other side. So I'm going to have y minus 5, 2 over 3. And this is going to be minus 5. And so what I'm going to do is I'm just going to multiply both sides of the equation with a negative sign to get rid of this negative. So multiply both sides of the equation with a minus sign, minus 1 and minus 1. So I'm basically going to get 2x positive 5 minus y minus 5, 2 by 3. Okay, and then I just go ahead, divide that 2. Okay, so I got this thing so far. Okay, so I just made x the subject. Now what I'm trying to do is I'm just trying to differentiate this equation with respect to y. So if this is dx, I'm just trying to differentiate all of this with respect to y. So that's what I'm going to do. So this is basically just going to be dx over dy, and I'm going to differentiate all of this with respect to y. And so this thing is a constant, so it's just going to be 0. And so I'm basically just going to have this. I'm going to differentiate this thing now, and I can basically write this thing as, I'm just going to erase a little bit of this stuff. can basically write this thing as 1 by 2. So all I'm trying to do is this 1 by 2 is a constant, so I'm just trying to differentiate this guy right over here. So I'm going to have negative 1 by 2, so that 2 by 3 is going to come down over here, and then I'm basically going to have y minus 5, and we're going to subtract 1 from that power, so that's just going to leave us with negative 1 by 3. So this is negative 1 by 3, and then we multiply this with a differentiation of this bracket. And so the differentiation of that bracket is just going to be 1, because if you differentiate y minus 5, this thing is just going to give you 1, and this thing is just going to give you 0. So you just multiply this thing with 1. And so what you're going to be left with is this is basically going to be dx over dy equals negative 1 by 2 multiplied by 2 by 3 y minus 5 raised to the power minus 1 by 3. And so I'm just going to come up over here, and I'm going to multiply these things. So dx over dy equals negative. 1 times 2 is 2, 2 times 3 is 6. So this is going to be 2 over 6. And then I have the y minus 5 raised to the power negative 1 by 3. So this, I believe, is my final answer. I can simplify this a little bit more if I want to, and I think I'm going to do that. So what I'm going to do is I'm just going to take this thing, since the power has a negative next to it, I'll just take it in the denominator. So this is going to be negative 2 over 6, and 1 by 3 basically just means a cube root. So I'm just going to convert this into a cube root, y minus 5. Okay, so this right here is my dx over dy, so I just found this thing, and all I need to do now is I need to multiply it with this thing. So that's what I'm going to do. So my dx over dt is basically going to be minus 5 multiplied by this entire thing, which is minus 2 over 6 cube root of y minus 5. And so dx over dt is basically going to be 10, because negative 5 times negative 2 is 10. And so I get this 6 cube root y minus 5. Now this thing is going to tell me how the dx, or how the x coordinate changes with respect to time. Okay, but now what I need to do is if you go back over here, I needed to find how my x changes with respect to t when y is equal to 32. So for this thing, what I'm going to do is I'm going to put my y as 32. So we're going to do that, and I'm going to have dx over dt equals 10 over 6 cube root 32 minus 5. So now what's going to happen is we're basically just going to solve this out. So this right over here is going to be 6. 32 minus 5 is 27. And so what's going to happen is if we cube root 27, we get 3. So this is 6 times 3, and it's 10 is being divided by this. So we are going to have 18 over 10, and the final answer is we can simplify this, and we'll just get 5 over 9. So 2 times 5 is 10, 2 times 9 is 18, so we'll get 5 over 9. So this is the rate at which the x coordinate changes with respect to time when y is going to be equal to 32. So we're on question number 10, part B, and it says point A on the curve has y coordinate 32. Point B on the curve is such that the gradient of the curve at B is negative 3, and we need to find the equation of perpendicular bisector of AB. Give your answer in the form this, where A, B, and C are integers. So what are they even talking about? So what they're saying is that they're talking about the same curve as they were in part A. So if I go back over here, so it's this curve right over here, this entire curve right over here, and what we're supposed to do is we basically have that curve and a point A. So this is point A. So at A, our y is basically 32, and then we're going to have some x value. I don't know what that is. I'll have to calculate that out. Okay, and then I basically have another point B. So I have another point B, and the gradient so the gradient over here, the dy by dx, the gradient is basically negative 3 over here. And so what I'm supposed to do is between these 2 points, I have this AB. So obviously there's going to be a line that's going to be called AB. What we sort of need to do is we need to find the equation of the perpendicular bisector of the line AB. So a perpendicular bisector is basically a line that cuts another line into 2 equal pieces. So basically if this line, we have this line AB, then the perpendicular is going to be a line that's just going to perfectly cut the line AB into 2 equal halves. So this half will be equal to this half in length. And this right over here will be the midpoint, of AB. And so what we need to do is we basically need to give them the equation for this perpendicular bisector line. So how do we do that? What's the plan? Well, first of all, what we're going to do is we're going to, well, if we need the equation of this perpendicular bisector, one way of doing that is using the point slope form. So the point slope form. And for that form, we're basically going to need the slope of this line as well as a point of this line. And the point is basically going to be the midpoint, the midpoint of AB through which the perpendicular bisector is passing through. So we can just use the midpoint, and the slope is basically going to be the negative reciprocal of the slope of line AB. So what I'm trying to do is if I can find out the equation of line AB, then I'll basically have the slope m of line AB, and so the slope of the perpendicular bisector is just going to be the negative reciprocal of line AB slope. And then if I have the equation of line AB and the coordinates of AB, I can basically use them to sort of find the midpoint, and then I'll just go ahead and plug the midpoint over here into the point slope form, and then I'll find the equation of the perpendicular bisector. So what I need to do is I first need to find out the coordinates of A and B. I don't as of now know the coordinates of A and B. So how I'm going to do that is so the first thing I'm going to do is I'm going to find the coordinates of A and B. So what I need to do is I need to first find out what the coordinates of A are. So I already know that the y coordinate of A is 32. I'm trying to find out the x coordinate. So one way I can do that is I basically have the equation of the curve, which is y equals, if we go up over here, it's basically y equals bracket 5 minus 2x raised to the power 3 by 2. So it's bracket 5 minus 2x raised to the power 3 by 2 plus 5. I'm just going to give that a little recheck. So it's 5 minus 2x raised to the power 3 by 2 plus 5. Yes, I think that is, yes, okay. 5 minus 2x 3 by 2 plus 5. Okay, so what I know is I know that this thing right here is 32. So I'm just trying to find my x. So let's just go ahead and solve for my x and find out what that is going to be. So this is going to be 5 minus 2x 3 by 2. 32 minus 5, I believe that is going to be 27. And then what I'm going to do is I'm going to send the power over there to the other side. So I'll basically just have 27 raised to the power, and the power is going to flip, so it's going to be 2 by 3. So this thing is 9, and this is negative 2x. This is a 5. Send the 5 over there to the other side. So this is just going to be 4. And then divide the negative 2 over there on the other side, and you'll just get negative 2. So this is the x coordinate. So the x coordinate of A is just going to be negative 2. So that's the coordinate of A. I found out the coordinate of A. Now I want to find the coordinate of B. So how do I do that? Well, they've given me the gradient for B. So what I'm going to do is I have my equation y equals 5 minus 2x raised to the power 3 by 2 plus 5. I'm just going to differentiate this. So dy by dx, and that is just going to be, so this is going to be 3 by 2, 5 minus 2x, and 3 by 2 minus 1 is just going to be 1 by 2, and then the 5 is just going to become 0 because that's a constant, and I'll also multiply the differentiation of this bracket, which is just going to be negative 2. So it's negative 2, and the 5 is going to turn into a 0, so I'll just put a plus 0 over there. So now my dy by dx is basically, this 2 is going to cancel out with that 2, so I'll just get negative 3, 5 minus 2x raised to the power 1 by 2. Now, this right here is the equation for the gradient, or the dy by dx of my curve. And so our point B is a place where the gradient is negative 3. So what I'm going to do is I'm just going to put this dy by dx as negative 3, and I'll basically find out my x coordinate. So I'm going to put this gradient as negative 3, and then this is negative 3. This is 5 minus 2x raised to the power 1 by 2. So this and this 3 are going to cancel out. I'm just going to be left with 1 equals 5 minus 2x. And this power of 1 by 2 just means a square root. So I can take a square on both sides. So this square is going to cancel out that square root, and 1 squared is just going to be 1. And I'm going to be left with 5 minus 2x. Okay, so 1 minus 5 minus 2x. And so this is just going to be minus 4. And so this and that cancel out, so I'll just be left with x equals 2. Now I found the x coordinate of B. I still have to find the y coordinate of B. So I have the original equation. I'm just going to go ahead and put my x coordinate in here and solve this equation for y. So I'm going to get 2 times 2 is 4, 5 minus 4 is going to be 1, and I believe 1 raised to any power just stays 1. I don't think it makes a difference what power you raise 1 to, but I'm just going to check it. Yeah, so 1 stays 1. So this is 1 plus 5, so y is just going to be 6. So the coordinates of B are actually 2, 6. So I've got my coordinates for A, and I've got my coordinates for B. So I'm just going to write my coordinates. A is minus 2, 32, and B is just, I believe B was 2 and 6. So B is 2, 6. So now what's happening is we found out our coordinates of A and B. What we can do right now is we can the gradient for the line A and B, or what we can do is we can find their midpoint first. So we can go ahead and find the midpoint, right? Or we can find the gradient M. So it's up to us. We can find this or this. It's up to us. And I'm just going to go ahead and find the midpoint first, and then I'll find the gradient. So the midpoint is just going to be so negative 2 plus 2 divided by 2, comma 32 plus 6 divided by 2. So negative 2, positive 2 cancel out. I'm just going to get 0. 0 divided by 2 is just going to be 0. And then 32 plus 6 is going to be 38. 38 divided by 2 is just going to be 19. So this right here is my midpoint. I found out my midpoint. Now I'm going to find out my gradient. So my gradient, m, is just going to be y2, which is 6, minus y1, which is 32, over x2. So over x2, which is 2 minus x1, which is negative 2. So this is just going to be 6 minus 32 is negative 26, and minus multiplied by minus 2 is going to be plus 2, so 2 plus 2 is 4, and then negative 26 divided by 4 is just going to give us negative 13 by 2. So that's the gradient of the line A and B. So this is the line A and B. Okay, so what we want to do now, that right there is the midpoint. We do know the coordinates of the midpoint. Now there's a perpendicular bisector, which means it's a line passing through the midpoint. And so if we want to give them the equation for the perpendicular bisector, we know that the gradient of this is just going to be the negative reciprocal of the gradient of line AB. And then we can use this midpoint and that gradient into the point slope form and find the equation for the perpendicular bisector. So what I'm going to do is I'm just going to use the point slope form, which is y minus y1 equals m x minus x1, and so my gradient is going to be the negative reciprocal. So if you take the negative reciprocal of negative 13 by 2, you get positive 2 over 13, and then x minus x1. So we're just going to look at the coordinates of the midpoint over here. So x minus 0, and then y minus 19. Okay, so we're just going to get y minus 19 equals 2x over 13, and then y is just equal to 2 over 13x plus 19, and this right here is the equation of the perpendicular bisector. Now there's one more tiny thing to do, and that is that we need to give the equation in this form. So that means that the x, y, and the constant term must all be on one side of the equation, and the other side of the equation must be equal to 0. So what we're going to do is we're going to rearrange this equation. So this is just going to be y, and we send the 19 over there to the other side. Y minus 19 equals 2 over 13x. And so what we're going to do is we're going to multiply this 13 over there to the other side. So we're going to get 13y minus 247. I believe that's what you get. Yes, you get 247. And so I'm going to have 2x over here. So what I can do is I can sort of take my 2x over there to the other side. So I'll have negative 2x positive 13y minus 247 equals 0. And you can see now I have all of my x, y, and constant term on one side of the equation and the 0 on the other side of the equation. So this is basically, it's our final answer.